Alright, you guys, well, we are here with the January exam review. I'm going to work out numbers 1 through 20 even, and then I'll stop and do another video for numbers 22 through 40 even, and then 42 through 60 even. So, if you need any extra help besides that, come into tutoring. We're going to start with number 2. You can go ahead and do the exponents first here. This whole section here is reminding you of PEMDAS and the distribution rule. Here we've got exponents, so 4 squared is 16, minus 9 on the bottom, and 27 minus 13 on the top. So you want to do the subtraction in your numerator and keep it on the top, so 27 minus 13 is 14 over. And then 16 minus 9 is, 7. So you get 14 over 7, and that does reduce to 2. So your final answer there would be 2. Number 4, this is similar to what we were doing this last unit with the square roots. When you're evaluating, you want to plug in where there's an x. I'm going to plug in 121. So you get negative on the outside, square root 121. That negative on the outside is like a negative 1. So I'm going to simplify the radical. The square root of 121 is actually 11. Breaks down into 11 times 11. So you get negative 1 on the outside of the radical times 11. Because this square root breaks down to 11. So negative 1 times 11 is negative 11. Problem number 6, solving the equation. You want to get that letter by itself, the x is by itself. The first thing I'm going to do is combine like terms here. Negative 5x minus 6x is going to be a negative 11x. We'll have that plus 14 equals 17. And you want to get the whole numbers over to one side and the letter all by himself on the other. So I'm going to subtract 14 to both sides to get 3 on the left equals that negative 11x. Then from there you want to divide by negative 11, cancel out here, divide negative 11 over here. So you're left with x on one side equals 3 divided by negative 11. That's your final answer because that cannot be simplified any more than it already is. Number 8, the word problem. It says the Ryan family's vacation budget consists of $500 for travel costs and $60 per day for other expenses. Write an expression to represent the cost of the vacation in terms of the days, D. So the first thing I want you to notice is this flat rate. Okay, the flat amount, the flat $500. That's what they have as a baseline. That's what they have to begin with. And, often plus, and $60 per day. We talk about in my class how that word per means multiply. So here we're taking that 60 and multiplying it by D, days. In this piece, write an expression. And when you're writing an expression, you don't have to solve anything. You just have to write these words in math terms. So here we are finished with this expression. 500 plus 60D. Turning the page for number 10. There's a new one called phi. You want to combine like terms. You want to get all of your numbers as simple as they can be. Here I notice I've got some x's and I've got some whole numbers. But my x's are trapped inside those parentheses. In order to get him out, you want to distribute this negative 2 to both pieces. Distribute the negative 2, not just the 2 itself, okay, because that sign right in front of the 2 goes with him. Negative 2 times x is a negative 2x. Negative 2 times negative 4 is positive 8. So you've got 9 minus 2x plus 8. Then you would combine your whole numbers. 9 plus 8 is 17. So you've got 17 minus 2x. We talked today about how you could write that as 17 minus 2x or negative 2x plus 17. And those are the same thing. The next section is on direct variation. Y varies directly with x. Write and use a direct variation equation. The direct variation equation is y equals ax, where a is the direct variation. Taught today, this is similar to y equals mx plus b. But in a direct variation equation, the b is always 0. So all we're looking to solve for is the m, which is the same as the a letter. B is 0, and we are given x is a negative 8 and y is 4. So what I'm going to do is take this y equals mx equation, and where there's a y, I'm going to plug in 4. I'm looking for m, and x I know is a negative 8. And I want to solve for m. Well, right now, m is being multiplied by that negative 8. So in order to cancel him out, I divide by negative 8. And whatever you do to one side, you have to do the other. So you're left with m equals, and then you've got 4 over negative 8, which is the same thing as negative 1/2. So my equation, if I go back to here and I plug it in, my equation is y equals negative 1/2 x. From there, it's a two-part question. It asks me to solve for y when x is 3. So I plug in y equals negative 1/2 times 3, which is the same thing as negative 3/2. So this would be the equation. This would be what y is when x is 3. Okay, direct variation. We take that one step further when we start talking about graphs. You know that the slope here is negative 2 because the slope is always the number right next to the x. Remember, y equals mx plus b. That's your slope, and that's your y-intercept. So my slope here is a negative 2. The y-intercept here is 0. So it's going to start at the origin. Remember, direct variation starts at the origin. So you're going to start here at 0, 0. Then that slope, that negative 2, same thing as negative 2 over 1, tells me to go down 2 over 1, down 2 over 1. You can continue that backwards to go up to left 1. And you connect the dots. We're going to talk some more about y equals mx plus b in this next section. Here, the slope is the number right next to the x, so that's going to be a 1. And your y-intercept is 1. Remember, slope is rise over run. So if my equation has a slope of 1 over 1, then I always start at the y-intercept. So I'm going to start at 1. Then I'm going to rise 1 and run 1. Rise, run. And we always run right to start off with so we don't get confused. Then if you want to work backwards, you can. See how you go from this dot to that one? You go down 1, left 1. So you can repeat that to extend your line backwards and connect your dots. Just a hint for number 19, you have to get it in y equals mx plus b form first. Okay, so move those letters over. Last one for today's video, writing two equations of lines that are parallel. Parallel means you're going to have the same slope. So you can write a bunch of different examples but as long as your two lines have the same slope, you are good to go. So let's say I start off with my y equals 2x plus 3. So my slope is 2 and my y-intercept is 3. A line parallel to that would have that same slope, but could have a different y-intercept, like that. Another example could be y equals x minus 4 and y equals x plus 10. Both of these have a slope of positive 1. Y-intercepts are different, but that's okay. As long as you have the same slope, your lines are parallel. That's it for today's video. Numbers 1 through 20 even.